Hello, in this lecture we will find the radius of a circle. As you can see in the drawing, we have a circle. The center of this circle is at point O. Inside the circle we have chord AD or string AD that equals to 10 units, and we also have another chord BC. Chord BC equals to 5 units, and this angle is 90 degrees, and we want to find the radius of this circle. Okay, first of all we will define what is a peripheral angle. Okay, so actually a peripheral angle is an angle that its vertex is on the circle and its curves are chords in the circle. So I will read again the definition of a peripheral angle. A peripheral angle is an angle that its vertex is on the circle and its curves are chords in the circle. Okay, so now I will give you an example of peripheral angle in order to clarify the definition. So actually angle alpha is a peripheral angle because of the fact that its vertex is point A. Point A is also a point in the circle, so the vertex of angle alpha is a point on the circle, that is to say it's point A that is a point on the circle. And its curves are chords in the circle. Curve AC of angle alpha is chord in the circle, and curve AB of angle alpha is the second chord in the circle. Okay, so a peripheral angle is an angle that its vertex here is on the circle. The vertex of angle alpha is on the circle. Point A is on the circle, and its curves are chords in the circle. Curve AC of angle alpha is chord in the circle, and curve AB of angle alpha is also the second chord in this circle. Okay, so that is actually a peripheral angle. Angle alpha is a peripheral angle. Okay, so actually in the next step we will draw a chord through points A and O. O is the center of this circle, and we will draw a chord through points A and O. Okay? Okay, I draw a chord through points A and O. We will define the touching point between the chord and the circle as point M. So actually, chord AM is the diameter of this circle. Okay, I will write it down. Chord AM is the diameter of the circle Why? Because chord AM passes through the center of the circle, that is to say point O. Chord AM passes through point O, that is the center of the circle. For that reason, chord AM is the diameter of this circle. Okay? Okay, I will read again what I wrote. Chord AM is the diameter of the circle because it passes through the center of the circle, that is to say, through point O. Because of the fact that chord AM passes through point O, that is the center of this circle. Point O is the diameter of this circle, okay? Chord AM passes through point O, that is the center of the circle. For that reason, it is the diameter of this circle. Okay? In the next step, we will connect together points M and D by a straight line. And we have a rule, I will call it rule number 1. Rule number 1 states that a peripheral angle that rests on the diameter of the circle equals to 90 degrees. I will read rule number 1 again. Rule number 1 states that a peripheral angle that rests on the diameter of the circle equals to 90 degrees. Okay, so I will give you example in order to clarify rule number 1. So if AB is the diameter of this circle, and the angle as you can see, the red angle rests on the diameter of the circle. That is to say, the red angle rests on chord AB. According to rule number 1, angle AOB equals to 90 degrees, because of the fact that any peripheral angle that rests on the diameter of the circle equals to 90 degrees. For that reason, angle A or B that rests on the diameter AB of the circle equals to 90 degrees. So this angle is 90 degrees. Okay, so it can be also from the other side, from the down side of the bottom side of the circle. We can draw a peripheral angle that rests on the diameter of this circle. So, because of the fact that the peripheral angle ACB rests on the diameter of this circle, that is to say, angle ACB rests on chord AB, that is the diameter of the circle, angle ACB also equals to 90 degrees. Okay, so any peripheral angle that rests on the diameter of the circle equals to 90 degrees. Okay? Actually, we can implement rule number 1 in our circle. Because we have angle ADM that rests on chord AB, that is the diameter of this circle. So according to rule number 1, angle ADM will be equal to 90 degrees. Okay, so I write it down. So, because angle ADM rests on chord AM, that is the diameter of the circle, so according to rule number 1, it equals to 90 degrees. So angle ADM equals to 90 degrees. Okay, I will read again what I wrote. Because angle ADM rests on chord AM, that is the diameter of the circle, according to rule number 1, it equals to 90 degrees. That is to say, angle ADM equals to 90 degrees. Okay, so angle ADM is a right angle. It equals to 90 degrees. According to rule number 1, because of the fact that angle ADM rests on AM, that is the diameter of this circle, it equals to 90 degrees. Okay? In the next step, we will connect together points A and B by a straight line. And we will focus on the right triangle AMD. Okay, on the right triangle AMD, we will define angle AMD as alpha. Angle AMD equals to alpha. Okay, so angle AMD equals to alpha. And we will define angle MAD as beta. So angle MAD will be equal to beta. Okay, this is our definition. So in the right triangle AMD, we defined angle AMD as alpha and angle MAD as beta. Okay, in the right triangle AMD, this angle is alpha and this angle is beta, according to our definition. As you have already know, in any triangle in the world, the sum of its angles equals to 180 degrees, especially in the right triangle AMD, it's the sum of its angles equals to 180 degrees. So I will create equation number 1 that states that the sum of the angles in the right triangle AMD equals to 180 degrees. That is to say, alpha plus beta plus 90 degrees equals to 180 degrees. So that is our first equation, equation number 1, that states that the sum of the angles in the right triangle AMD equals to 180 degrees. That is to say, alpha plus beta plus 90 degrees, that is the sum of the angles in right triangle AMD, equals to 180 degrees. That is our first equation. Now we will subtract from equation number 1 90 degrees. So we subtracted from equation number 1 90 degrees. Alpha plus beta plus 90 degrees minus 90 degrees equals to alpha plus beta, and 180 degrees minus 90 degrees equals to 90 degrees. Now we'll subtract from equation number 1 alpha. We subtracted from equation number 1 alpha. Alpha plus beta minus alpha equals to beta. 90 minus alpha equals to 90 minus alpha. So beta equals, according to equation number 1, beta equals to 90 degrees minus alpha. Okay. We also have rule number 2 that states that peripheral angles that rests on the same chord / arc equal to each other. Okay, I will write it down. Peripheral angles that rests on the same chord equal to each other. So I will read rule number 2 again. Rule number 2 states that peripheral angles that rests on the same chord equal to each other. So actually now I will give you an example of rule number 2 in order to clarify it. If we have two peripheral angles, this peripheral angle is angle alpha, and we have another peripheral angle peripheral angle beta, as you can see from the drawing, angle alpha rests on chord BC and also arc BC, and angle beta also rests on the same chord BC, or you can say also arc BC. So according to rule number 2, because of the fact that angles alpha and beta rests on the same chord, they are equal to each other. So according to rule number 2, angle alpha equals to angle beta. Because of the fact that those two angles rest on the same chord, that is to say on chord BC, they are equal to each other. We can also say that they rest on the same arc BC. Okay? So because of the fact that angle alpha and beta rest on the same chord or the same arc, they are equal to each other according to rule number 2, alpha equals to beta. Okay? So if we have two peripheral angles that rests on the same chord, like in the drawing, those two angles alpha and beta rests on the same chord BC, they are equal to each other according to rule number 2. Alpha equals to beta. Okay? So actually we can implement rule number 2 in our circle. So maybe you cannot see the picture because it was not it was like this. So now I will repeat again. Because of the fact that angle alpha and beta rests on the same chord BC, according to rule number 2, they are equal to each other. That is to say, angle alpha equals to angle beta. Okay? These two angles rest on the same chord BC. For that reason, according to rule number 2, they are equal to each other. Alpha equals to beta. Okay, so I repeat it because you maybe didn't see the picture. It was hidden. It was not in the camera. Okay? So we will implement rule number 2 in our circle. Angle AMD that equals to alpha rests on chord AD rests on chord AD, but angle ABD, again angle ABD also rests on chord AD. Okay, I read again. Angle AMD that equals to alpha rests on chord AD, but angle ABD also rests on the same chord AD. Angle ABD also rests on the same chord AD. So according to rule number 2, we can deduce from rule number 2 that actually they are equal to each other. That is to say, angle ABD also equals to alpha. Okay, according to rule number 2, because of the fact that angle ABD rests on chord AD and angle alpha also rests on chord AD, they are equal to each other. That is to say, angle ABD equals also to angle alpha. Okay, angle ABD also equals to angle alpha because of the fact that both peripheral angles rests on the same chord AD. Okay? So I will write here that angle ABD equals to alpha. Okay, so that will be angle alpha. Because angle ABD equals to angle alpha. We will call this point L. So in the right triangle ABL, we will define angle BAL as angle X. Okay, angle BAL equals to X. Okay, in the right triangle ABL, we define that angle BL will be equal to X. Okay, so I write here that angle BAL equals to X. So in this right triangle ABL, the sum of the angles equals to 180 degrees, and it is true for all the triangles in the world. The sum of the angles in any triangle equals to 180 degrees. So we write down that alpha plus X plus 90 degrees, that is the sum of the angles in the right triangle ABL, equals to 180 degrees. Okay, so I will write it down. So equation number 2 will be alpha plus X plus 90 degrees equals to 180 degrees. So equation number 2 states that the sum of the angles in the right triangle ABL equals to 180 degrees. The sum of the angles in any triangle equals to 180 and 80 degrees, and especially the sum of the angles in the right triangle ABL also equals to 180 degrees. Okay, now we will subtract 90 degrees from equation number 2. So we subtracted 90 degrees from equation number 2. Alpha plus 6 plus 90 degrees minus 90 degrees equals to alpha plus 6. 180 degrees minus 90 degrees equals to 90 degrees. Now we will subtract alpha from equation number 2. We'll get that x equals to 90 degrees minus alpha. So we subtracted alpha from equation number 2. We got that alpha plus x minus x equals to x. 90 degrees minus alpha equals to 90 degrees minus alpha. Okay, so equation number 2 states that x, angle x equals to 90 degrees minus alpha. But according to equation number 1, beta also equals to 90 degrees minus alpha. This is equation number 1. Beta equals to 90 degrees minus alpha. So I'll write it down. Okay, according to equation So according to equation number 1, beta also equals to 90 degrees minus alpha. So equation number 2 states that x equals to 90 degrees minus alpha. So we can say that x equals to beta, or if you want to show it in the long way, (90 degrees minus alpha equals to 90 degrees minus alpha). We will subtract x by 90 degrees minus alpha. We'll substitute 90 degrees minus alpha by x in this side of the equation. We will substitute 90 degrees minus alpha by beta in this side of the equation. We will get that x equals to beta okay, we got that x equals to beta, and we actually can write here instead of x, we can write here beta, because x equals to beta. So I will delete x, and instead of x I will write beta, because x equals to beta. Okay, so angle BAL equals to beta, and also angle MAD also equals to beta. So we actually have rule number 3. Rule number 3 states that equal peripheral angles rest on equal chords. So I will read again rule number 3. Rule number 3 states that equal peripheral angles rest on equal chords. Now I will give you an example in order to clarify the meaning of rule number 3. So actually, if we have two equal peripheral angles, so this angle, this peripheral angle is angle alpha, and this peripheral angle is also angle alpha, okay. In this circle we have two peripheral angles that equal to each other. This peripheral angle is angle alpha, and this peripheral angle is also angle alpha. According to rule number 3, because of the fact that those two peripheral angles equal to each other, according to rule number 3, they rest on equal chords. So according to rule number 3, we can deduce that DE equals to BC. Okay? Again, because of the fact that those two peripheral angles equal to each other, they both equal to alpha. According to rule number 3, they also rest on equal chords. That is to say, DE equals to BC. Okay, they rest on equal chords and also on equal arcs. Okay, and add to rule number 3, the equal peripheral angles rests on equal chords and also on equal arcs. Okay, equal peripheral angles rests on equal chords / arcs. Okay, so because of the fact that those two angles equal to each other, both of them equal to alpha, they also rest on equal chords. That is to say, chord DE equals to chord BC. Okay, this is according to rule number 3. And actually, we can implement rule number 3 in our circle. As you can see, this angle is angle beta, and this angle is also angle beta. So according to rule number 3, equal peripheral angles rest on equal chords. That is to say, BC equals to MD. So because of the fact that angle BAC equals to angle beta, and also angle MAD equals to angle beta, according to rule number 3, they both rest on equal chords. That is to say, BC equals to MD. Okay, because of the fact that angle BSC equals to beta, this angle equals to beta, and also angle MAD equals to beta, so those two equal peripheral angles also rest on equal chords. That is to say, BC equals to MD. Okay, so according to rule number 3, because of the fact that those two angles equal to each other, according to rule number 3, also BC equals to MD. They both rest on same chord, that is to say, BC equals to MD, okay? BC equals to MD. Okay, but we know that BC equals to 5 units. Okay, BC equals to 5 units. It is given us in the question. Okay, we know from the question that BC, chord BC equals to 5 units. It is given us in the question. So we can deduce from it that MD also equals to 5 units, okay? Okay, BC equals to MD, BC also equals to 5 units, so we can deduce from these two expressions that MD also equals to 5 units. So we actually can write here that MD equals to 5 units according to rule number 3. Now I will draw right triangle AMD again. So this is right triangle AMD. Actually, chord AM is the diameter of the circle because of the fact that it passes through the center of the circle. We have already discussed this issue. So we will call chord AM, we will define it as D, that is abbreviation for diameter, because AM is actually the diameter of this circle. So we will call it D, we will define it as D, and actually we will use the Pythagorean theorem in order to find out the size of D, the size of AM, that is the size of D. As you already know, the size of any diameter equals to 2 times the radius. And after we will find out the size of D, we will divide the outcome by 2 and we will get the radius of this circle. Okay? First of all, I will write down the Pythagorean theorem. So actually the Pythagorean theorem apply only to right triangles. So I write that in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So I will read again the Pythagorean theorem. The Pythagorean theorem states that in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so we actually can implement the rule in our right triangle. So according to the Pythagorean theorem, in our right triangle AMD, in right triangle AMD, the square of the hypotenuse, that is AM square, the first equation, AM square equals to MD square plus AD square. Okay, the square of the hypotenuse, that is to say AM square, equals to the sum of the squares of the perpendiculars, that is MD square plus AD square. Okay, but we know that AM equals to D according to our definition, MD equals to 5 units and AD equals to 10 units. So we can substitute AM by D, we can substitute MD by 5, and we can substitute AD by 10. Okay? Okay, so actually we substituted AM by D, so instead of AM square we will get D square. We substituted MD by 5, so instead of MD square we got 5 square, and we substituted AD by 10 because AD equals to 10, so instead of AD square we got 10 square. So actually 5 square is 25 and 10 square is 100, and 100 plus 25 equals to 125, so I write it down. Okay, we got that D square equals to 125. Now we will take a root out of equation number 3. We'll get that so we took a root of the equation number 3. So root of D square is D, and the root of 125, instead of 125 we can write 25 times 5, because 25 times 5 equals to 125, so I write it down. Okay, instead of 125, I wrote 25 times 5. Now we can split the root to two roots according to the rule that root of a times b equals to root a times root b. Okay, according to this rule, root of a times b equals to root a times root b, we can write that d equals to root 25 times root 5. Okay, we split the root to two roots according to this rule. As you already know, root of 25 is 5, so I write it down. So we got that d, the diameter of the circle, equals to 5 times root 5. As you have already know, the diameter equals to 2 times the radius. Okay, the diameter equals to 2 times the radius. Again, the diameter equals to 2 times the radius. We got that d equals to 5 times root 5, so we can substitute d by 5 times root 5 because d equals to 5 times root 5. Okay? So, in the fourth equation, d equals to 2 times the radius, we substituted d by 5 times root 5 because d equals to 5 times root 5. So we got that 5 times root 5 equals to 2 times the radius according to equation number 4. Now we can divide the equation number 4 by 2 and we will get the radius of the circle. So we divided equation number 4 by 2 and we got that the radius of the circle equals to 5 times root 5 over 2. And if you want to know, it is units of course, and if you want to know the radius of the circle in terms of numbers, it actually equals to 5.59 units. Okay, so the radius of the circle equals to 5.59 units. Okay, the radius of this circle equals to 5.59 units. Now I will summarize the lecture. Actually, we wanted to find out the radius of this circle. First of all, the definition of peripheral angle is an angle that its vertex is on the circle and its curves are chords in the circle. So this is a peripheral angle. The vertex of angle alpha is at point A, that is on the circle, and curve AC of angle alpha is a chord on this circle, and also curve AB of angle alpha is a chord in this circle. Okay, so a peripheral angle is an angle that its vertex is on the circle. This is to say, in this example is in point A, that is a point on the circle itself, and its curves are chords in the circle. Curve AC is chord in the circle, and curve AD of angle alpha is also a chord on this circle. Okay, so that is the definition of peripheral chord, peripheral angle. And actually we draw a chord through points A and O. Actually, point O is the center of the circle, and we also know that chord AD equals to 10 units and chord BC equals to 5 units, and this angle is 90 degrees, and again point O is the center of the circle. And we actually draw chord through points A and O, and actually we defined the touching point between the chord and the circle as point M, and actually chord AM is the diameter of the circle because it passes through the center of the circle. That is to say, it passes through point O, that is the center of the circle. For that reason, chord AM is the diameter of this circle. Okay? Then we actually connected together points M and D by a straight line. And as you can see from the drawing, angle ADM rests on AM, that is the diameter of this circle. Again, angle ADM rests on AM, that is the diameter of this circle. And we have rule number 1 that states that a peripheral angle that rests on the diameter of the circle equals to 90 degrees. Okay, so if, for example, AB is the diameter of this circle, and we have this angle that rests on the diameter AB, it equals to 90 degrees, and also the right angle that rests on the diameter AB, it also equals to 90 degrees according to rule number 1. So we actually can implement rule number 1 in our circle, because actually angle ADM rests on chord AM, that is the diameter of this circle, and according to rule number 1, angle ADM equals to 90 degrees. Okay, very simple. Okay, because of the fact that angle ADM rests on the diameter of the circle, according to rule number 1, it equals to 90 degrees. Okay, and then we define the angle AMD as alpha, and we define angle MAD as beta in the right triangle AMD. And we also know that in the right triangle AMD, the sum of the angles equals to 180 degrees. It's true for every triangle in the world, especially in the right triangle AMD. So we can write equation number 1 that states that the sum of the angles in the right triangle AMD equals to 180 degrees. That is to say, alpha plus beta plus 90 degrees equals to 180 degrees. This is true for every triangle in the world. Okay, and we got that beta equals to 90 degrees minus alpha. That is our first equation. Beta equals to 90 degrees minus alpha. Then, according to rule number 2, peripheral angles that rest on the same chord equal to each other. We actually connected together points A and B by a straight line. So rule number 1 states that if we have two peripheral angles that rest on the same chord, in this example angle alpha rests on the chord BC, and angle beta also rests on the same chord BC. So according to rule number 2, they are equal to each other. That is to say, angle alpha equals to angle beta. Okay, so we can implement rule number 2 in our circle, because we have angle alpha that rests on chord AD, and we have also angle ABD that also rests on the same chord AD. So according to rule number 1, according to rule number 2, angle ABD also equals to angle alpha, because both of them rest on the same chord AD. Therefore, they are equal to each other. So if this angle is alpha, this angle is also alpha, because both of them rest on the same chord AD. Okay? So angle ABD equals to alpha. And in the right triangle ABD, in the right triangle ABL, we defined angle BAL as x, and we know that the sum of the angles in any triangle equals to 180 degrees. So we got the equation number 2 that says that in a right triangle ABL, alpha plus beta plus 90 degrees equals to 180 degrees. Equation number 2 states that alpha plus x plus 90 degrees equals to 180 degrees. So we got that from equation number 2 that x equals to 90 degrees minus alpha. But according to equation number 1, beta also equals to 90 degrees minus alpha. So we can deduce from it that x equals to beta. So we can write here instead of x, angle BAL equals to beta. Okay? So angle BAL equals to beta, but angle AMAD also equals to beta. And according to rule number 3, equal peripheral angles rest on equal chords / arcs. So actually, if we have two peripheral angles that equal to each other, this angle is alpha and this angle is also alpha. According to rule number 3, because of the fact that they equal to each other, they also rest on the same, on equal chords. That is to say, DE equals to BC. Because of the fact that they equal to each other, they also rest on the same, on equal chords. That is to say, DE equals to BC. So we actually can implement rule number 3 in our circle, because we have angle beta here and we have angle beta here. And according to rule number 3, because of the fact that those two peripheral angles equal to each other, they rest on the same, on equal chords. That is to say, BC equals to MD. Okay? According to rule number 3, BC equals to MD because of the fact that those two angles equal to each other. Okay, so according to rule number 3, BC equals to MD. BC equals to MD. But we know from the question itself, it is given us in the question that BC equals to 5 units. Okay, BC equals to MD from one side. From the other side, BC also equals to 5 units. So we can deduce from it that MD also equals to 5 units. Okay, BC equals to MD and BC equals to 5 units. We can deduce from it that MD also equals to 5 units. So actually we have the right triangle AMD. We know that MD equals to 5 units, AD equals to 10 units, and AM, it is the diameter of the circle. We defined it as D. Okay, this is right triangle AMD. Side AM of the triangle is the diameter of the circle, side MD equals to 5 units, and side AD equals to 10 units. So according to the Pythagorean theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So we can use this theorem in order to find out the size of D. So according to Pythagorean theorem, AM square equals to MD square plus AD square. Okay, AM square equals to MD square plus AD square. but we know that AM equals to D, AD equals to 10, and MD equals to 5. So we can put the data inside the equation, and we actually got the final answer that D, the diameter of the circle, equals to 5 times root 5. Okay, but we know that the diameter of any circle equals to 2 times the radius. Okay, and we already found that the diameter equals to 5 times root 5. So we can substitute D by 5 times root 5 in the fourth equation. So we substituted it, and we got that 5 times root 5 equals to 2 times the radius. Then we divided equation number 4 by 2, and we got that the radius of the circle equals to 5 times root 5 over 2, or the radius equals to 5 times 59 units. The radius equals to 5 times root 5 over 2 units, or the radius equals to 5 times 5.59 units. Okay, so the radius of this circle equals to 5.59 units. Okay, thank you very much.